Good morning, students. Today there is a seminar class. Usually I invite all my students to present the seminar classes. If you are going to present seminar classes, it implies that you have understood the concept of the subject. So today one of my students, Ms. Gayatri, she is going to present a seminar on spin of the electron, spin angular momentum of the electron. The concept of spin arose in the year 1921 by Stern-Dirac experiment. So Stern and Dirac both they introduced the concept of spin in the year 1921. After 4 years, it was given a full understanding by Uhlenbeck and Goldsmith. So they said about spin plus of and minus of, and later, after 2 or 3 years, it was fully brought out by Paul Dirac. So Paul Dirac was deriving the relativistic equation. He gave the exact concept of spin, which is nothing but h bar by 2 and minus h bar by 2. So then onwards, the fourth quantum number is considered as a spin. So we know about the principal quantum number, then orbital quantum number, then angular magnetic quantum number. It's about angular momentum, and fourth one is about spin. The spin is very important quantity. It's intrinsic property. So it was fully done by Paul Dirac. So I am so happy that one of my students is going to present the seminar, and let's enjoy the seminar. Thank you.
Good morning to all present here. Myself Gayatri Lakshmanan. I am pursuing my final year PG degree in physics in Govt Arts College, Melur. Let's move on to the topic. My topic is spin of the electron, spin angular momentum of the electron. Spin of Dirac electron. It was first experimentally just done by Stern and Dirac, but on that time there were no awareness about spin. Then in 1925, Uhlenbeck and Goldsmith explained clearly about the spin concept. They said h bar by 2 is that spin. For spin up, we got plus h bar by 2, and spin down, we got minus h bar by 2. Spin cannot be determined independently. The spin of the electron carries no energy. The spin in an electron is an intrinsic property. That means the spin of the electron is inbuilt. The spin of the electron is not a particle. It is associated with the wave. It can be coupled with the orbital motion of the electron. This can be demonstrated through the conservation of total angular momentum and through the spin orbit coupling energy. J equals L plus S. Here L is the orbital angular momentum and S is the spin momentum. Spin. This only I am saying that spin cannot be determined independently. The spin of the electron alone will not exist. Along with the orbital angular momentum, we get total angular momentum J equal to L plus S. Dynamical variable commutes with the Hamiltonian. Then the orbital angular momentum is given by L equals R vector cross P vector. In Heisenberg picture, the rate of change of Lx is given by, we are going to consider Lx. We are going to consider Lx is given by I, this is the equation of motion, I h cross del x by del t, dt equals Lx comma h. This is the commuting property. Lx comma h equals 0. This is a commuting property. Here Lx is the constant of motion. By using Dirac Hamiltonian, we have Lx comma h equals y pz minus z py comma c alpha dot p plus beta mc square. In this we can write alpha and ps in terms of the coordinates alpha x px and alpha y py plus alpha z pz plus beta mc square. Then I h cross dlx by dt equals y pz minus c alpha y py minus z py comma c alpha z pz. Since here alpha and beta commute with r and p, all other commutators vanish. So only here there exists only alpha terms and beta terms. I h cross, then this equation 3 can be written as IH cross dLx by dt into C alpha y, here is one mistake, here y, py, pz minus C alpha z, z, pz, py. IH cross dLx by dt equals IC h bar alpha y pz minus, that means previous this y py, ICH alpha y pz minus alpha z py, because we already said that the other commutator's terms are vanishes. Here Lx comma h not equals 0. This is not a commuting property. The answer is exists here. This is not equal to 0. Then this equation 5 shows that Lx is not a constant of motion. Similar relations holds good for Ly and Lz. Like Lx, the similar relations also comes for Ly and Lz. Hence the orbital angular momentum L is not a constant of motion. Then the addition contribution comes from the operator H sigma dash, where sigma prime is given by sigma prime we can written in the matrix format sigma 0 0 sigma. Sigma dash means new term in we are going to include new term in magnetic moment. The equation of motion of its x component is, then we are going to consider the x component. Then we are going in sigma prime x. Previously we write del Lx. Here we are going to write IH bar d sigma prime x by dt equals sigma prime x comma h. In this include the Heisenberg equation sigma x prime c alpha p plus beta mc square. Then this alpha and p we are going to expand it in terms of components alpha x px plus alpha y py plus alpha z pz plus beta mc square. Since sigma dash x commutes with b, then equation 8 becomes c sigma prime x alpha x px plus sigma prime x alpha y py plus sigma c into sigma x alpha z pz. We previously said sigma prime equals sigma 0 0 sigma. Then for sigma x we can write sigma x 0 0 sigma x, alpha x we can write 0 sigma x 0. Then we are going to multiply this sigma x into 0 0 0 into sigma x 0. So the first answer is 0. Then sigma x into sigma x square plus 0 into 0, sigma x square plus 0 gives sigma x square. Then this 0 into 0 0 plus 0 into sigma, this 0 into 0 0 sigma x into sigma x square. Then this 0 into sigma x square is 0, sigma x into sigma x into 0 0. We know that sigma x square equals 1. Therefore we can written here 0 1 1 0. This is the unitary matrix, so we can write this as 1. Then in this we conclude that sigma x and alpha x. Then for first term we need to expand in another term also, alpha x and sigma prime x. So we need to interchange these two. Then alpha x becomes this 0 sigma x 0 and sigma prime x 0 0 sigma x. Then multiply, we get the same result like this 0 sigma square x 0 0 1 1 0. Then answer equals 1. Now sigma prime x alpha x minus alpha x sigma prime x equals 1 minus 1 equals 0. Similarly for this is first term. Similarly for second term and third term, if we do this process like this, we get the answer 2i alpha z and minus 2i alpha y. Then equation 9. This is the equation 9. Substitute these values, this sigma dash x and sigma x y, sigma z, this value we are going to substitute in equation 9. So IH bar is sigma prime x by dt equals, first for sigma x we observe 0. Then sigma y we obtain 2i alpha z. 2i alpha z py minus 2i alpha y minus c 2i alpha y pz. From these two we are taking 2 ICS common, minus 2 ICS common. Then we can write alpha y pz minus alpha z py. In this, we bring this 2i to this side. Then I and can becomes cancelled. We get h bar by 2 d sigma prime x by dt equals minus c alpha y pz minus alpha z py. Then equation 5. This equation 5 we can be written as dlx by dt equals c alpha y pz minus alpha z py. Then we are going to, because see the RHS term both are equal, so we are going to add these two. If we add this 11th and 12th equation, we get d by dt of lx plus half h bar sigma prime x equals 0. We know here dlx by dx not equals 0. In the previous slide we say that lx is not a constant of motion, so this is not equal to 0. But if we add half h bar sigma prime x, it becomes 0. d by dt lx plus half h bar x sigma prime x equals 0. Therefore, this is the differential form. If this term is equal to 0, then this term becomes constant. Lx plus half h bar sigma x becomes constant. It is clear that Lx plus half h bar sigma dash x commutes with the Hamiltonian and can be taken as the angular, and this can be taken as the angular momentum also. For sigma prime matrix, it can be written as, we can written the sigma prime matrix as sigma prime x bar x square, sigma prime y square, sigma prime z square equals 1. This gives the eigenvalues of half h bar sigma as plus half h bar or minus half h bar. This is the conclusion of the slide. Hence the additional part we can say that S equals half h bar sigma prime equals half h bar sigma 0 0 sigma. It can be interpreted as spin angular momentum. This is, we can interpret this as the spin angular momentum of the electron. Thus the concept has evolved from the Dirac Hamiltonian. The Dirac proved this in this spin of the angular momentum. Thank you.